Today, we're looking at your car's air conditioning system. We'll see how it works, see a brief history and evolution of the air conditioning system in automobiles, and bust some common myths. We'll also identify some signs of a failing AC and learn how to best maintain it. So hop in and let's get going. Once a luxury, air conditioning is now a standard feature on most modern vehicles. We rely on the AC to stay cool and comfortable, especially during the hot summers. Did you know that your car's air conditioning system doesn't generate cold air? Actually, it draws moisture and heat from the air in your car. The AC system works by circulating refrigerant, converting it from gas to liquid, and then back again. By the end of this cycle, it sits in a cold, gaseous state inside the evaporator. When the outside air gets blown through it, it gets cooled and then sent to your car cabin. The standard components that make up a car's air conditioning system include the compressor, condenser, receiver dryer, evaporator, and the expansion valve, or orifice tube if you have an American vehicle. Each of these components serve a different purpose. All these components are used with the refrigerant. The success of the system is based on the refrigerant's ability to change its physical properties during compression, cooling, and metering. So let's follow the path and see how it works. First, we start with the compressor, which sucks in low pressure, low temperature refrigerant, which is in gas form. It compresses it into a high pressure, high temperature gas. Then, this flows through the hoses and enters the condenser, which is very similar to a small radiator. The condenser's job is to capture the heat of the hot refrigerant. Air flows around the condenser, which cools the refrigerant down, causing it to condense and turn back into a high pressure but lower temperature liquid. In addition, when the refrigerant starts to cool slightly, condensation forms in the refrigerant. Next, the high-pressure liquid refrigerant enters the receiver dryer. The receiver dryer is a canister that contains a desiccant and a filtering system. Maybe you're wondering, what's a desiccant? Well, a desiccant is simply a substance that absorbs water. It's the same packet substance you can find in some shoes or medications to keep them fresh and dry. Now, the filters of the receiver dryer remove debris like dust, dirt, and metal particles that can harm the AC systems. Its dryer removes moisture. So why is it important to remove moisture? If you don't remove the moisture, when the refrigerant reaches the outlet expansion valve, it may be cold enough to freeze. This, in turn, can clog the expansion valve and lead to a malfunctioning of the air conditioning system. So, once the refrigerant is cooled down sufficiently, it gets directed to the thermal expansion valve. An expansion valve is essentially a regulator. It regulates how much refrigerant can pass through the air conditioning system. Put another way, imagine you're holding a water hose. When you apply pressure to the nozzle, it expands and sprays the water like a mist. Well, that's similar to how the expansion valve works. The process not just lowers the pressure, but also quickly cools the refrigerant. So at this point, it comes out in the form of a mist from the expansion valve into the air conditioning pipeline. The refrigerant is now at a low pressure and low temperature. It's now nearly ready to cool the interior of your car and now needs to pass through the evaporator. The evaporator works like a radiator or condenser, but it doesn't dissipate heat. Instead, it absorbs heat. That's because previously, when the refrigerant passed through the evaporator, it lowered the temperature to about 32 degrees Fahrenheit. Interestingly, unlike water, which freezes at 32 degrees Fahrenheit, the refrigerant boils. This causes the refrigerant to convert back to a gas, which allows it to absorb heat from the air passing through the evaporator. At this point, the gas flows back into the compressor and continues the cycle. So when does the cool air enter your car's interior? When the refrigerant is in the evaporator. A fan pushes the outside air through the cold evaporator tubes, which causes the air to cool. When you push the AC button, that's when the air enters your car cabin as cool, refreshing, air-conditioned air. Nowadays, it's hard to imagine a car without air conditioning, but this wasn't always the case. In the early days of the automobile, people simply didn't have the luxury of air conditioning. It wasn't until 1939 that the first vehicle with factory air conditioning was actually produced. But the idea for an air-conditioned automobile took root much earlier. Throughout the 1930s, car manufacturers saw a need for a cooling system and they started experimenting. For example, in 1930, a Texas resident custom-made a Kelvinator system for his car. General Motors chief researcher Charles Kettering loaded ice blocks in the back of his Cadillac town car. to measure the energy needed to cool the vehicle. Other companies experimented too, but theirs tended to be heavy, noisy, and inefficient. Researchers had a lot of issues to resolve. For starters, they needed a system that was small enough to fit in a car, and they also needed to find a non-toxic and non-flammable refrigerant, so you wouldn't go down in flames if you got in a wreck. Ultimately, GM developed a Freon-based cooling system that worked well, but it was Packard that first produced the first air-conditioned cars in 1939, and that was with their 1940 Senior 160 and 180. Initially, the car maker integrated its air conditioning system, not into the dashboard as we're used to today, but in the trunk of the car. Cadillac and Chrysler followed its lead with similar systems, but air conditioning in vehicles didn't become mainstream at that time because it was quite expensive, yet still primitive. After World War II, car manufacturers began to offer air conditioning in some of their cars. Most systems were installed in the rear of the vehicle, just like with the first Packard models. By the 1970s, over 70% of new cars had AC systems. But now, let's look at some common myths. What's more economical for your car, using the AC or rolling down the windows? Well, it seems like a simple question, really, but it isn't that simple an answer, especially since you need to consider several different factors. To begin with, the outside temperature plays a big role. Other factors are your driving speed, engine size, make and model of your car, as well as the condition of the air conditioner. According to the U.S. Environmental Protection Agency, EPA, cranking up the air conditioner when outside temperatures are high can increase your gas consumption by up to 25%. Also interesting to note is in the same scenario, fuel consumption was found to be even higher in hybrid vehicles than in conventional combustion engine vehicles. All that said, according to the same EPA study, using the AC may be more efficient than leaving your windows open when you're driving on the highway. The main reason is that open windows increase aerodynamic drag and forces the engine to work harder and burn more fuel. So here's the rule of thumb if you're concerned about gas consumption. In general, if you're driving at speeds over 40 miles an hour, it's better to close the windows and set the air conditioner at a low level. But when you're driving slower than 40, it's better to turn off the air conditioner and roll down your windows. Unless you live in Houston, Texas in the summer and you get so hot you'd melt. At the speed, wind drag isn't a significant factor, so the engine won't be pushed to overcome air resistance. Here's another myth. Is it possible to start the engine when the air conditioner is turned on? When you turn off your car, you're turning off the power, and all connected systems are automatically turned off as well, including the AC. Some people believe if you turn on the engine without shutting the AC off, the AC's compressor will face a massive power load on startup, and that repeatedly starting the car with all the systems on will ultimately shorten the life. Well, that was true with older cars with carburetors decades ago. But nowadays, with modern cars, that's no longer the case, because modern cars have air conditioning units that are designed to shut off automatically when the starter is engaged. So for this reason, we can say that is a myth. What about turning on the AC system when you're on a steep hill? That's another common myth, by those who say using an air conditioner while going uphill makes the engine work harder and makes the car more prone to overheating. The reality is that the air conditioning systems of today's cars are designed to work with all but the absolute extremists of conditions. So the systems will automatically divert power to the engine as needed. You can enjoy riding up the rolling hills with the cool breeze of your air conditioner in any modern car. Nothing could be more frustrating than a broken AC on a blazing hot summer day. So how can you tell if your AC is failing? Here's a few things to look out for. If the cold air is weak or the cold air doesn't blow at all, that may indicate that the air conditioning evaporator is leaking. That would affect the efficiency of the AC system. The larger the leak, the lower the cooling capacity. Another sign is a strange smell when you use the AC. This too can be due to a leak from the AC evaporator. A small amount of refrigerant can be the culprit. Usually the refrigerant has a sweet smell which intensifies when the air conditioning gets turned up. What if your AC compressor doesn't turn on? That can be yet another sign there's a leak in the system, which causes the pressure to drop, causing the computer to shut the compressor off using the pressure switch. Another sign your AC unit is failing is if the temperature of the cool air is inconsistent. This too can be due to faulty or damaged evaporator. If you hear high-pitched noise coming from your AC, that may be a sign that the pressure switch or sensor is failing. The switch can rattle against various parts of the engine compartment, so it's best to check this before any parts get damaged. So how much does it cost to repair a faulty AC system? A complete replacement of the AC system, including removal of the condenser and installing a new one, can run anywhere from $600 to $5,000 in some Mercedes. And that's just for the parts. Keep in mind, though, you have an additional $300 or so for the labor cost. Unless you're talking Mercedes, in which case it would be thousands to take a dash apart. That's why regular maintenance can go a long way in extending the life of your car's air conditioner. So here are a few helpful tips on how to extend the life of your AC. For starters, turn on the air conditioner in the winter. It wicks humidity away from the interior of your vehicle. But don't worry, most cars you don't even have to do that. When you put the defrost on, it automatically turns the air conditioner on in most modern cars when the heat's on and defrost is turned on. This will also help to reduce windshield fog for better visibility. Defrost for 10 minutes from time to time to prevent mildew and moisture buildup. Turn on the air conditioner at least once a week for 5 to 10 minutes. Set it to maximum power at the coldest level. This will help ensure your compressor continues to operate at regular gas pressure levels and spreads the oil internally of the system so it's lubricated correctly. But now you tell me, do you have any funny or horror stories related to your car's AC system? Please comment below and share. If you like this video, please subscribe to my channel. Thanks for your support.